आवाज पण चांगला येतो. Nishant sir? Nishant sir, am I audible?
Hi, Sharmista. Hello.
Nishant sir, am I audible?
Yes, you are audible.
Sharmista,
My screen is visible.
Sharmista,
Hanji sir.
link is sent to all the participants regarding the YouTube. Okay, you can mention that.
Just a second, sir. The volume is very low. I'm not able to hear.
It's okay.
Yes, sir. Hanji, boliye, sir.
You can mention that the link for joining on your YouTube channel. The link has been sent to all the participants who
Okay.
join the link also.
Okay, sir. So, shall we start with the session? So, I suppose our next lecture will be on role of light in quality grape production by Dr. Nishant Deshmukh, sir. He is working as a senior scientist in food science at NRCGrapes. And the whole lectures, you can also link to the YouTube channel or NRCG channel. There the lectures are, because out of some technical glitch, only 100 participants can be added. And in YouTube, these lectures are there. So you can see it from YouTube also. So Nishant sir, you can start.
Thank you, Sharmista, for a nice introduction. Good afternoon to all of you. Can you hear me?
Yes, sir, but your volume is very low.
Volume is low. Now?
Yes,
Hello.
sir. Yes, sir, it's fine. PPT mode, इसमें slide mode पे कर दीजिए, sir.
Now it's okay?
Yes, sir. You can start, sir.
Yeah, good afternoon to all. It's a nice to be with you and interacting with you on one of the important topic. This is one of the new topic where we are concentrating on to how to identify the role of light for quality grape production. I would like to welcome all of you, and I would like to thank all of you for putting your participation and joining for this 3-day training program, which is funded by Manage. So with this, I will start my lecture. Within this lecture, we will understand about the light spectrum, light quality, how light will influence, then light parameter, that is temperature, then humidity, all these things, how it will be affecting the crop, then how to identify light sensitive or light tolerant or highly photoefficient genotypes with the use of some sophisticated equipment, and how the spectrum of light is influencing the overall quality. This lecture is not just related with the grapes, but this will give you the in general idea what is going to be happen in the near futures to come. We are expecting the rise in temperature. We are expecting the diurnal variation in low and high temperature. So all these things, I am trying to combine all these things which are related to the projected climate change or the climate change we are experiencing at our location specific conditions, those who are influencing our life. So I would like to cover all these things so that you can relate this. It may be possible this lecture may you get bored, because it is a somewhat like an academic lecture where you are getting what we studied in our textbook. Same things I am repeating here to getting you refreshing your knowledge about the what need to be done in the futures to come, whether it is a grape production or either production of any crop. So with this, you all know the grape is a C3 plant, and when the temperature goes below 10 degrees centigrade, it's initiated its activity, and once temperature above 35 degrees centigrade, the plant start triggering adaptation mechanism. So this is the case with the grapes, and we are in a tropical climate. I hope that there are the participants who are from temperate region, tropical region and subtropical climate, temperate region. That is Jammu Kashmir and then northeastern part, they are having a temperate climate. Basically, since the morning, the lectures have been taken by the various eminent scientists. So you understand that this is a crop of temperate region, but we have tailor-made it and make it suit to our tropical conditions. Now, a tropical region, that is arid tropical region, which is comprising of Pune, Karnataka, nearby area, having the about around 70% area under the production of this crop, and this is the main export potential area from the where grape is exporting. And you may aware that now we are seeing the temperature is continuously rising and rising. So this is another threat. I hope that there are the participants who are from the line department, from the various state government, and they are facing a similar so many issues, so many new threats, so many new physiological threats, so many abiotic and biotic stresses. All these things are happening because of this low, mid, or indiscriminate availability of light, or it may be because of we are not able to harvest what the natural light is with us. Before going to that, I would like to take you to some preliminary information. What wavelength? We called it as a spectrum wavelength, and we in the college during the degree time you all study. There are three. We have divided: infrared radiation, visible radiation, ultraviolet radiation. Just for your remembering your basic, I am just putting, because afterwards I am talking about light wavelength, light spectrum, light quality. So this lecture we are concentrating on what is its influence on photosynthetic efficiency. Because if light is the issue, then we have the problem with photosynthetic ability, and we have the ultimate effect on the ultimate quality and the grape yield. So with the visible range, we all remember red, green to red. This is visible light. The green to red. Here only actual photosynthesis is happen. That we call as a significant photosynthesis. If the light is that is infrared, it will have a thermal effect on the plant, though it is a grape or any crop. And second most, I would like to your attention. We are getting farmers are constantly pressing us, and they are telling us, sir, this year we got such type of symptoms. There may be the cane cracking, there may be the splitting of cane, and there may be the diseases which has been less pronounced earlier. Now it is highly pronounced. So we are initiated the work. Though maybe students are here. We have started the work on quantifying ultraviolet A, ultraviolet B, and ultraviolet C. Now we have initiated some works on the ultraviolet A, because to conduct some experiment on UV radiation, you need some sophisticated facilities. We are at National Research Center for Grapes. We are trying to create these facilities so that we can understand what is the effect of this lower wavelength, that is 400 to 100 nanometer, that is ultraviolet A and ultraviolet B, because these are having a significant effect. And being a C3 plant, you all know there are C3 plants, C4 plant, and CAM plants. So being a C3 plant, it is a more sensitive if there is a slight variation into the light quality. Because we are, if you stand now, this is the 13th March, and those people who are from the tropical climate, from at least from 12 to 2 o'clock, we can't able to stand in the sunlight because of the high intensity of radiations. So this is one of the reasons plants are also surviving with this light. Temperature is 35, 36, 37 degrees centigrade now, but the light intensity is very high, and they may having infrared radiation, or that may having the ultraviolet radiation, which are influencing the crop, influencing the photosynthesis system, that is photosystem 1 and 2, and that ultimately triggering the productivity. So this is basically with the wavelength. Hope you all are understanding what I am saying, and I think that after this lunch, this is a slippery time. So I would like to request all of you, if you can start your video, so that I can see you on my face and we can discuss more. So if all are comfortable, they can start their videos so that we can have a good interaction, because I don't want anybody to sleep. I had a slot of 2:30 to 3:30, that means 60 minutes. So each minute I want not to make you bored, but give you some insight on the how this wavelength of light has and the wine response has been changing. Thank you all for starting your videos. Those who have not started, they may start. Uh, this picture you can Google. You get this picture. This is a 380 to 750. This is a visible light, and this visible light we can measure. We had the instrument light measurement system we had, and with this light measurement system we are quantifying the visible light which is falling on the plant surface. Problem is how to quantify this X-ray, that is UV light. This has become a constant challenge, and across the globe, so many scientists are working on this. How to quantify the effects. These experiments are quite successful under the protected structure. Those having high-tech facilities, they are doing it under protected structure. We are influencing some UV light on the plant system, and then we are understanding its effect. You all maybe agree with me that UV light doesn't having a good effect on the crop. So considering this, we have to manage our production practices in near future too. This is a photosynthesis. All we are aware, this is a carbon dioxide, water that will give glucose and oxygen. I'm just reminding you with this diagram, and here I want your attention. We know the stomata, stomatal and opening and closing is most important to take out the carbon dioxide. Carbon dioxide, you all aware that the level of carbon dioxide has been rising constantly. In the nature, we are measuring that one, and IPCC, that climate change committee, they have projected something which I will show you later on. So here you just understand that stomata is an important source for the absorption of carbon dioxide inside the leaf. Then we get light from sun energy as a light source. And this chloroplast, you all studied during your graduation, chloroplast trap the light energy, and water enter from the leaf, and the sugar from the leaves, and then we produce the carbon. We can call it the photosynthetic, we can call it the carbon, we can call it the sugar that is used as the ultimate food for the plant. Here the most important is one is the chloroplast, and second is the stomata. If stomata get disturbed by so many means, so then carbon dioxide will not be able to enter into the system. Despite of available of good light, we are not able to harvest, do the better photosynthesis and to produce the fruits. We all know the concentration of chlorophyll affect the rate of reaction. They absorb light energy needed for this reaction. This is related to the chlorophyll. If it is deficiency, then we see the chlorosis and yellowing of the leaf. These are the general things which is happen with the. That means your leaf should be green in color. If your stomata should be function properly, it should be open and close at the right time. Then and then only we can get the carbon dioxide inside the leaf and the light from the sunlight, and with the help of carbon dioxide and water, we are producing the fruits. Now, when we coming to the grapes, we have done some experiment that results I will tell you in the subsequent slide. If 100% light has been fallen on the leaf surface, this is the leaf surface, I would like to tell you 90% light get absorbed by the leaves. So grape is a C3 plant. It is a light loving plant. That's why maybe the organizer found it fit to have one lecture on the role of light in a grape production. 90% light get absorbed, 4% light get transmitted, and 6% light get reflected back to the environment. So that means around 90% light has been used by the leaf. So this grape leaf is a so interested in the absorption of light. So the whole crux of this presentation lies here only. If you understand this, in 90% light it get absorbed by the one leaf, what happened to the second layer of leaf, third layer of, because we have a canopy, we have a trailing system, that is we have a bower system, we call it as a mandap, then we have Y-shaped trailing systems, then we have a expeller system. All this training system has their different capabilities. And then we have a different layer of crops also. So on the top, light is falling on the leaf. I will show in the subsequent slide. If you can see here, we have done this experiment with Super Sonaka. If you see, I told you earlier, we have a light measurement system. With the use of that, we have been measured how much power has been fallen on the top of the leaf. If you see top of the leaf and the bottom of the leaf, only 74% power we have measure at the bottom of the leaf. That means I will tell you this book, the photographs I have given here, this book has been published by Smart in 1980s or 81.
Nishant sir?
I was disconnected.
Yeah, you have to again share your screen.
Is my screen is visible?
Yes, you have to make it on slideshow.
So this is a phototropism. We all have been studies ki, as the light moves, the oxygen molecules and the plant will start bending. You may be aware of about the famous experiment of bending with the GABA. The plant get bent, and because of that, we have to be manage the.
Okay, Nishant sir, sorry to interrupt. Some people are saying that it is not visible. Is it with any participant? Please let us know. Is it visible? Slides are visible. Audio is okay.
Is visible, madam.
But somebody is on the message has written that.
Okay, okay.
Please ask him. Please check him.
Let them respond, ma'am.
Please, any participant respond. Is the slides and audio visible? Yes. Okay, sir. You can continue.
Okay. But I wanted some participants should be start their video and they should interact with us. Because
Please, voluntarily participants, please switch on your video so that we can come to know that there are some people other the other side also.
because when you are understanding the word light transmission, then phototropism, I also used to get sleep, but this is my duty and my job. I have to work on it. So I would like to discuss all these things with you. Every time when we study, we think what if the photosynthesis has been developed, where it go? Photosynthesis, we develop the carbon, we develop the sugar. In the grape, it is allocation is to the expansion of young leaf, then partition to the fruits, leaves, new roots, trunk. This is the basic key when the photosynthesis has been developed, where it's moved. These are the some of the photographs. If you can understand, this is the fruit pruning. That is we called as the ponga stage. Then it is called as a bunch emergence. Then it is shoot thinning. This parrot green stage. Then flowering stage. This is the flowering stage. That's fruit setting, veragen, and this one is the maturity stage. I just put these photographs so that you understand that we are concentrating on the grapes and showing the different stages. And now here is the crux. The moment of photosynthesis in grapevine should somebody has to understand. Otherwise, we can't able to go for managing the spray of nutrient or the spray of gibberellins or the spray of PGRs or the spray or the manipulation of canopy. So if you study, see this, from the floral development to this graph is going up and up so that the photosynthetic movement at different stages has been given. That's why in the grapes we go for shoot thinning at different stage, at different time, and at different intervals. If you see the berry development, that is the berry is one of the important parameter in grape. So if you see the berry development, here I would like to make your attention particularly related to the xylem movement. If you see up to 30 days, xylem absorption of water and dissolved mineral from the xylem is very high. But after 60 days, the second stage has been started when the phloem is more active, which carries the food made into the leaves, photosynthesis in all over the part. Initial lecture, Dr. Ramteke has told you related to the number of leaf and number bunch to fruit ratio, that is leaf, number of leaf, that this much number of leaf has to be taken. If the bunch is there, then there should be the 10 to 12 leaves above the bunch, because in the initial phase, we wanted to develop a maximum food that can be used for developing the bunches, developing the berries in the days to come after 60 days. These are the different phases. Ultimately, I will share you these slides so that you will understand the better knowledge about it. Then you all know the water is an integral part. Stomatal opening and closing is related. Water shortage along with the light has a negative effect on the any crop. In your nutrition lecture, you heard about it. We can't do photosynthesis with the absence of light or water. So these are the important parameters when we are talking about the quality grape production. And then another important point, Sharmishta, can you hear me?
You are audible, sir.
Yes, sir. Yes, sir.
Okay. Thank you. Thank you. We are constantly facing a one challenge, particularly in tropical condition with the temperature. Temperature fluctuation, there are a very humidity, seed germination, reduction in the plant. So many issues are related with the temperature. The few I would like to highlight and make your attention that ideal temperature is 20 to 30 centigrade. But ideal doesn't happen anytime. Ideal is ideal only, and we constantly get temperature which is up to 40 or maybe 42, 43. And we are also getting a temperature which are going below down 10 degrees centigrade, which may be around 4 degrees, 6 degrees, 7 degrees in some part of the Nashik, and 42, 43, 44 degrees, 45 degrees centigrade in some part of Solapur and all. So the fluctuation in temperature has been leading to the susceptibility of the vine to the different biotic and abiotic stresses. This one thing we have to understand. I would like to tell you, if the photosynthesis is better, then the tolerance limit of the plant has been grow, and if the tolerance limit will be grow, it can be fight with the number of insect pest diseases and the biotic and abiotic stresses. These are the some of the I have been informed that there are students who also have joined this seminar. For them particularly, I would like to tell them, if you see the sugar, this is a graph, this is relative concentration, and this is the temperature. Once temperature rises, sugar content will also increase in the grape wine. It doesn't mean it will constantly increase. Once it is going above 35 degrees centigrade or 40 degrees centigrade, then sugar levels start dropping down. We call it as a reversal of sugar. Then malate enzyme is similar, tartarate is similar, one is potassium, and some of the students who are doing graduation or post-graduation, they might understand about this proline. Proline is a stress hormone. Once the stress will increase, proline content will decrease. So these are the indicators that we have to take into the consideration whether the plant is in under stress condition or non-stress condition. Then anthocyanin. Now in grape growing area, we are seeing there are the orchards for the colored variety, particularly red globe and crimson. The farmers are growing it with the good management practices, and this variety also have one problem related to the ununiform color development. This color development issue, once the temperature started rise after winter, color development will be faster. But if it is temperature goes rise more than 30, 35, 40 degrees centigrade, then the color development is an issue with this colored variety, which having high demand during the export. So the management of this any variety or management of the grape vineyard, we have to constantly monitor what is the temperature inside your vineyard, outside your vineyard, what is the humidity, prevailing humidity, how the wind has been flowing. So these parameters gives us what are the protective steps has to be followed. Second, another important is with this temperature only, Optimum temperature, I put here 25 degrees centigrade, then I put 30 centigrade as the high temperature. If you consider tropical condition, this range may be 30 and this should be 30, should be 35. If the temperature rises, at optimum temperature, we get rise in TSS, rise in malic acid, flavonoid content, anthocyanin content. But if it is higher than 30 degrees centigrade, then we see the decrease in the content of this TSS, anthocyanin. What we have seen in the earlier slide, it is just a pictorial depiction of this. So all the farmers who are all the students, whenever you are visiting the vineyards, whenever you are visiting any grower site, try to understand what is happening. If farmer is saying the reverse is reverting, sugar is reverting means what? It may be due to the high temperature. Sometime I will share you the one story from our Nashik. Nashik, we are getting some early prunes vineyards which harvest their produce in the month of November, December, and January. And during this period, last 2 to 3 years, we are facing one issue. We have a sugar content for the export that should be 16 degree Brix. Then the sugar acid ratio that should be around 20:1. Now, I would like to inform the house, we have been revised the sugar acid ratio in collaboration with the AgMark, and the gazette notification has been already published. So if the sugar acid ratio is 18:1, I am repeating, the students, they may get this question during the NET examination. Sugar, now the revised sugar acid ratio is 18:1 instead of 20:1. So this has been done because our early growing crops, particularly from the Nashik region, we are constantly facing the problem of less drop down of acidity. Acidity was constantly above 1 and 1.5 degrees centigrade. Because of that, we doesn't get better sugar acid ratio. Then we done the experiment over the 2 years, and we come out with this conclusion that 18:1 should be the sugar acid ratio for the grapes which are producing from the early season. So this type of R&D, this type of manipulation, this has to be done by us. This has to be done by the researcher, so that our export doesn't get hampered and we get higher revenue. Another one thing, this is also an academic slide. If you see here, instead of air temperature, soil temperature, if the soil temperature is low, that is also has a negative effect on the growth. The soil temperature should be around 15 to 20 degrees centigrade. This all I would like to mean with the response of temperature into the grape vine. Now, if you are talking about the low light, that means the low temperature or cloudy weathers, we are facing this issue in our region. Decreasing terminal shoot growth, this is one of the obvious reasons. Then decreasing fruit set, you may all agree with me. Delay fruit maturity, reduce the color, reduction in acid degradation, fruit cluster, reduction in number of, these are the, and main important is the spread of insect pest and diseases. So these are the one reason. I always used to say proper canopy management. Without proper canopy management, that has been told to you by Somkar sir in the morning. He has shown you the different slides before, and he might have talked about light harvest or light energy harvest. Why he talk about this? Because these are the reason. If there is a cloud dense canopy, we get more infestation of insect diseases and insect pests. So the proper canopy management is the most important. Second, I would like to bring your attention to the CO2 and its reaction with photosynthesis in the grapevine. You all can understand. Now the current level of this CO2 is 410. This graph I was make 2 years back. This is a quite old graph. And if you see, this is the dotted line is a C4 plant, and this is a dark line, this is a C3 plant. How C3 plants are going to behave if the CO2 level going to be double in the near future, and we are expecting this by 2021. I think this is now the 2025. We may be there or not, but our kids will be definitely there. They will see 2021. And if this double also, this will be not hampering the quality of the C3 plant and also the grapes. But problem is not just the CO2. problem is with the increasing the temperature, that will have another negative effect on the growth. But now, as of now, whatever the information we have, whatever the information available in the open source, we can say the CO2 increase, rise in the level of CO2 has the positive effect on the photosynthesis of the any crop. Then this is a classical photographs which I have taken from the one of the book. If you grow the crop in the shade, then you doesn't get fruiting. You get vegetative cycle only. You need a light for a balanced cycle. So this simply signifies the role of light in the quality production of the grape wines. Secondly, I am sharing some of the slides where we have done the experiments on the light spectrum, its quality, and how it is utilizing. I would like to share you, we have the rootstock, that is 110R. You heard about doggery, you heard about 110R, you heard about 140RU, you heard about 103P. But in the futures to come, under the changing climatic condition, I will tell you this 110R is one of the rootstock. The area which is having cloudy weather for longer period of time, this rootstock will definitely going to work. This is what our research finding has been told. So in the near future, we have to promote this rootstock to combat with the cloudy weather, which is persist for quite longer period of time. Second, this is also the similar data which is showing what happen in cloudy weather and the sunny weather. Secondly, if you go to these slides, I request the students who are working on any climate change experiment, any carbon sequestration experiment, this is the information for you. We have been screened the different varieties, how they are responding under the cloudy weather. When the cloudy weather is prevailing in our vineyards, at the same time we use our light measurement system, and we are recording how they are performing. And I would like to tell you, the Manjri Navin is a variety which has been developed by the National Research Center for the grapes, followed by Crimson. They are performing better if there is a cloudy weather also. This doesn't mean that they will not susceptible to the disease and pest, but compared to other, they are much tolerant and they can be grown in the future, the area where this type of conditions will be prevalent. This is one photograph I have taken from one of the finest scientists. He worked in Israel, and I was with him for a couple of days. And this slide is of him, how the red light and blue light is affecting the crimson seedless and its various light spectrum. It is quite visible. I was already in initial slide told you there are visible light. In the blue light, we initiated the growth. In the red light, we get the better growth. But if light is more than this, 780 nanometers, then it is infrared light that is not good for the crop growth. This experiment which has been done under the protective structure, these are the findings. That means we need a light, not just light, but the good quality of light. We are under our institute, we are doing some projects to identify the light saturation and light compensation. This is nothing but our blood pressure. We have a 80 to 120, 80 down and 120 up. This is a blood pressure range. So many of you are aware. So similarly, I told you that if plant get good light, it will go for doing photosynthesis and photosynthesis. But there is a limit also. At a higher limit, it doesn't do the photosynthesis. Instead of rate will be stay constant. That we will say it is a saturation. And the point, if this is this information is useful when we are talking about to grow grapes in a wide agroclimatic condition, from the traditional area to non-traditional area having low light availability. If suppose we talk about the Mizoram, Arunachal Pradesh, they are having hardly 4 to 5 hours of light availability. Then under that condition, they need a genotype, they need a variety which can be produce optimum photosynthesis, which can produce optimum yield under that much light availability. To identify this, we do the such experiment. With this, we quantify, this is a IRGA system. With the use of this, we identify what is the saturation point and what is the compensation point for the varieties. And initially, we are screening some 4 or 5 varieties. And we find out that the Bangalore Blue are from the selected varieties, because we have not taken the whole lot of varieties. We are working on it. phase by phase we are studying, because to come out with this reading or come out with this light requirement, you have to record the observation more than 50 times. And then you have to calculate the data. So initially we are screening out the variety. This information definitely going to be used when we wanted to introduce the new variety in a new agroclimatic conditions, and that too depend upon its photosynthetic efficiency, and that too depend upon the sunlight availability, that is light hour availability in that particular agroclimatic conditions. This is a you may have been earlier speaker show you at least 30% light has to be fall inside the canopy. I told you that 90% light get absorbed. If 90% light get absorbed, then what about the leaves which are on the lower side? They should not be just parasite on the top leaf, those who are producing the do the photosynthesis, so that our canopy should like that 30% light should be passed throughout the canopy. This is the basic reason. This is the cane maturity. For the cane maturity, cloudy weather, it will delay the cane maturity. Shoot pinching we do, side removal of side shoot we do, control the irrigation. These are the practices to deal with this cloudy weather or weathers which are not suitable for the growth. These are the practices. I told you that we wanted to harvest higher light energy. This is a free light. We have to meticulously use our resources so that we can harvest maximum light towards our benefit. So our canopy should be open. We should remove the excess shoot, removal of side shoot, the appropriate spacing between the shoot. These are the few things which all of you has to be taken care of during the canopy management and canopy regulation. If the light harvest will be hampered, I must tell you, your number of spray will be increased significantly. This is the one photograph, direct 2021. This is from Sangli. We were visited. There is a Krishna River, and the orchard was all the orchards will be under the water for at least 3 to 4 days, and the whole photosynthesis was stopped. So we have initiated some first recommendation was given by us to clean the leaves, because here all the silt has been deposited on the surface of the leaf, and we wanted before initiating anything we have to clean the leaf so that the photosynthesis get activated, and after photosynthesis get activated we can think about the different management practices. These are the practices we have been told today, how to manage these types of vineyards. And this is one tiger birds. You may get this information in Sonkor sir's presentation also. Light should be fall on this tiger bird, then only this will be the fruitful. This is a very important bird. This is necessity for the fruitfulness. Then the timely shoot thinning. This is the one of the practice we have to do regularly when we are managing the vineyards. This is another classic example. When I visited to the farmers field, farmers, those especially go for domestic. Those who plan for export, they maintain 10 to 12 tons. Accordingly, they manage the bunch load. But those who are planning for domestic, they are not manage the bunch load with that precision, and they keep higher bunch load. If you keep higher bunch load, that means photosynthesis which has been made by these leaves, whatever the photosynthesis has been done by this leaf, and the photosynthetic, that is carbon and sugar, has been reserved in the cane, that will be go waste in the form of thinning. So a lot of energy was wasted if you are not managed proper source to sink relation. So with this, my message to all of you, manage the bunch load as per the requirement, as per the target, whether it is for export, whether it is for domestic, or whether it's for resin purpose. So you have to manage that much load only, so that in the thinning itself, you should not require to remove the large number of these are the around 8 to more than 8 to 10 mm size. Though this is not a stage. If you remember, I told you the berry metabolism and growth stages. The purpose of showing that slide, purpose of showing that basic study, that means What is the role of what the role of xylem? Xylem will transport the minerals, transport the water which is needed for the photosynthesis. It's required by the vine up to 160 up to 60 days is more. After that, the role of phloem start. It doesn't mean the role of phloem doesn't start early. The role of xylem and role of phloem is continued, but the rate will decrease slightly. After 60 days, phloem role will be more, and the phloem, whatever the photosynthesis, whatever the sugar, whatever the carbon which has been developed through the photosynthesis by the vine, that will be taken by the via phloem to the bunches, to the aerial parts of the plant, and that will use for the development of berries, high development of good size berries. Earlier lecture you talk about the use of GA, use of different PGR for cell elongation, thickening and all. If we understand this basic mechanism and harvest good light, then I must tell you the number of doses will definitely come down. Then we have initiated some work in another our project to the carbon dioxide and this powdery mildew. Inhibition of CO2 fixation in the leaf infected by powdery mildew fungi is in the powdery, that is CO2 fixation will be reduced down if the leaf is infected by the powdery mildew. Anybody can understand, because they are reduced down the leaf surface, leaf area that is required for the active photosynthesis. These are the visible symptoms. What is happening? Initial stage, there will be no chlorotic symptoms on the leaves. Then after 4 to 5 days or 6 days, we see the chlorotic symptoms. Then the rust disease also, it affecting the CO2. With this, I'm not reading the slide, but in my last slide, I will talk about this slide, because the initial in the future works we are undertaking on this. That is, I told you the stomatal opening and closing is most important for the CO2 fixation inside the leaf. If the powdery mildew will be more, it will inhibit the stomatal opening, and that will reduce the transpiration rate, and ultimately the rate of photosynthesis will be affected. So these are all are the interrelated things. Early detection of disease, early detection of stress, whether it is biotic and abiotic, is a crucial for the management of grape vineyard, which is having high remuneration. With this, I would like to tell you, this is how this is infecting downy mildew, and we have measured this downy mildew infection with the help of our IRGA system. You can see this is 2000 par. At 2000 par, healthy leaf do the photosynthesis around 7.78. And if it is infected by downy mildew, see this is infection, then the photosynthesis rate is reduced by only 2. That means only 25% photosynthesis, and that too we are not sure whether it is giving good or not. That's why this is one of the important area where we have to manage. Then prerequisite, farmers are now aware. I must tell you, they are using a precise spray, but still, if the number of spray with the use of stickers, then we see such type of coating on the surface of the leaf. If such a type of coating on the surface of leaf, that will definitely hamper the transmission of light inside the leaf. If you see, if so, some of you having this solar systems, we have seen the solar system in different houses farmers are using to get free light using solar panels. And if solar panels you doesn't clean, then the efficacy of light harvest will be reduced. The same case is also with this grape leaf. If this leaf is coated with such type of chemical, then we can't expect that this will go for better photosynthesis despite of maintaining number of leaves and all. These are the few suggestions which I will sharing you in my lectures and on the presentations which will be sharing to you. Allow only 17 to 18 leaves per shoot, then do shoot pinching, then maintain bunch load, positioning of bud to the sunlight for higher fruitfulness, 30% sunlight should be passed to the canopy, and maintain balanced source to sink ratio. Whatever we discuss during these slides, I think there are 43 slides, and this is all is related with the just a summary of this. Now, those the students, I must got information. There are some students who are joining, who also joined for this training program. And with this, I would like to share, because of this slide is for them only. Presently, we are working on an IoT-based vineyard microclimate monitoring system. We had the project with IIT Mumbai, and this project we wanted to, whatever I told you initially, there are stresses. Suppose it is powdery mildew, and powdery mildew after infection, we able to know the visible symptoms after 4, 5, or 6 days. That means huge time has passed. So this is microclimate monitoring system. This is our challenge program. So the first time in the country, we wanted to understand what is happening inside the canopy so that we can able to detect early stress. For this type of projects, we are hiring also those students who are interested to join hands with National Research Center of Grapes for their PhD or PG program, and willing to work on a climate change and related theme. They can contact us. We will like to welcome them, and some of you may have get chance to get opportunity with this project. So another project which we are working on, developing robotic harvesting system. This is also project funded by NSF New Delhi. Here we are concentrating on robot, those who can help in doing different farm operation inside the vineyard. Now we are talking about precision agriculture. We wanted to improve the mechanization. It is a highly mechanized crop, and we wanted to have human touch free crop. So we are working on this also with the CIE Bhopal. It's regional station in Coimbatore. One of our group is working, and we are trying to develop this type of structure also. Another one is we are also identifying, working on screening of light and photosynthetic efficient genotypes. You might have heard people are developing the varieties or concentrating on yield should be more than 15%. The variety should be higher yielder. Despite of good yielding capacity, despite of good coloration, variety is not able to extend to the from this belt to another belt because of this. This is in the climate change scenario. Harvesting of light and improving the photosynthetic efficiency is an area where we are working, where we are initiated our work. And another work we have initiated on metabolomic studies of studies. So those students or researchers, those who would like to collaborate us in the near future, they can contact us through the coordinator. We would definitely like to help. With this, I would like to thank to all of you for giving me your time. And with this sleepy time, I hope I have not able to make you sleep. With this, I would like to thank to all of you.
Thank you, sir, for the lecture. It is, I know after 2, it's very difficult to even sit, and it's a bit academic, but still you have shown, and you've been able to tell us like what is the importance of light, and how it, especially if you have to go grow grapes in some of the areas which are still non-traditional and not exploited. These things can be, thought about, and this is a very helpful information. If anybody has some questions, you may please ask her right now.
I think Suman Seth had joined from UBKV. Someone joined from UBKV? Suman.
Dr. Nishan sir,
Huh.
one question is there. First of all, I will appreciate your presentation. It's very precise, nicely. And the thing is that you mentioned about the requirement of the light, particularly in the grapes. So may I know if you are growing the grapes in different pockets in India? So everywhere the light intensity is different. So we are talking about the growing degree days or heat units. So anybody want to grow the varieties in particular regions. So how you will elaborate regarding the growing degree days relationship with wine varieties in relation to the particular region in India?
Yeah, very nice question and well elaborated question. With this, my answer will be one line. We have to identify the genotypes. We have to screen the varieties on the basis of sunshine our requirement. Different regions having lower sunshine, higher sunshine, mid sunshine. On that basis, we are working on to identify the genotype that can be suit in that particular climatic condition. That's why I was interested. Some was joined from the UBKV. They are interested to grow the grapes under at UBKV and the Kalimpong and the near West Bengal. So I would like to listen from them what is their plan. So I don't think he is available here or not.
Probably not joined, sir. Otherwise, may have given the reply.
But his name is coming here
Yes, yes.
because we had a plan to going to the non-traditional area, particularly with our wine varieties, particularly in this UBKV, then Nagaland, then Arunachal Pradesh, and we are expecting with the use of this photosynthetic efficient genotypes, which we wanted to take up further. It will give us the positive results in the futures to come to recommend some good varieties under that agroecological conditions.
Sir, so second question is that you told about the sugar acid ratio. So now it is being changed, as you mentioned, and it has been approved already. So what will happen in future? Can you give your gist on that?
Yeah, this is again a relevant question. Relevant in the sense that first of all, I would like to bring kind attention of my all students, all fellow researchers. 2004, we have developed standards for the grapes. TSS should be above 16 degree Celsius. TSS acid ratio should be around 20:1. This has been approved during 2004. And these were the ICAR standard, which has been developed by the research organizations based on the available data, available scientific information at that time. Now the 20 years has been passed and the grape growing has been expanded like anything. And now when we talk about the October pruning, October is a major season of fruit pruning. Now the farmers are going for pruning right from the September, right from the July and September. Why they are doing so? Under European Union conditions, then in the global exports, we have a high demand for the crops early, that is November, December, and the first or second week of January. Because during this period, there is a less availability of produce from the other global markets. So to catch up these markets, farmers have been changes their pruning times. And when they are doing so, they are getting that is mandatory 16 degree Celsius, that is sugar. I told you if temperature is around 25 degrees centigrade, sugar will be developed. But the problem is happening with acidity, it doesn't drop down with this temperature. Because of this, November, December, and early January, we having a somewhat cold temperature. And the region I'm talking about is the Nashik, where the winter temperature, some of the pockets goes to 4-5 degrees centigrade. And this is the early blade where the export-oriented grape production was there. And they are facing the problems despite of getting good sugar, acidity was not dropped down, and then the 20:1 ratio was not maintained. And if that ratio was not maintained, AgMark will not give them the certificate to go for export. And that is really hampering our export. This year only, what I came to know, somebody has told me yesterday, I was there in Nashik. Early season exports, now we can able to increase. Suppose we exported to 100 containers. This is an example. From the next year onward, we can expect during this early period of this, our export will be increases up to 150. That means 50% rise in the export of grape produce with the just reduction in this level has been happened. Again, I would like to tell you, some people maybe have this issue. If this 20:1 has made 18:1, whether it has any impact on the quality. So we have done the experiment right from start, we are doing it. And the various forum, various research paper, we recommended 18:1. This is not new. Suddenly we came to one problem and we are recommending you go for 18:1. 18:1 also quality of grapes is quite good. And when this harvesting happen and export happen. Another example I will told you with this regard. We all know we are having issues with Israel and the Gaza Patti. They have several issues, and then the export which is from the Sudan Canal has been affected drastically. And now the farmers has to go to the South Africa and Cape Town, they have to go to the Europe. So the 15 days duration has been extended to 25 days. So the freight charges is also increasing. And so for all these purpose, we need some of farm fruits which can be withstand under this increase in the durations and in the market also. And another third point I would like to share you, sweet grapes preferred by us only. If you go to the Europe, they like slightly acidic grapes. So that 18:1 more suited to them and also to us. This is the genesis for making this 18:1. And this will be, we are hoping that this season, this coming season, that is 24-25, we must get a higher increase in the early export of the grapes from the country.
Thank you, sir. My another next question is that, sir, there is change in the temperature range, very flexible, particularly after the ripening period, after the horizon period of maturity of the grapes. So in that minimum period, grapes are getting more ripened, and particularly in a region where tropical climatic conditions. So what's your view about that? If there is a harvesting of the grapes at the same time from all part of particular region, so there might be it might be affecting the prices in the market. So what's your view about that?
I'll bit skeptical on talking on this topic, but if what experience show, this rise in the temperature after the veraison stage may lead to the early harvest. So what we plan we have to prune on 15 October or 1st October, 1st November. We have to now change your pruning time so meticulously, because if one variety will take 130 to 140 days to get maturity, this rise in temperature may lead to 5 to 10 days reduction in the harvest period. So early maturity we can expect in many varieties, and this problem we are facing constantly in our vineyards also. We have harvested at 15 days interval, but once the temperature start rising in the first week of February, and we get all the varieties which have started ripening down. That means sugar acid ratio develop. So the challenges in front of students or researchers who are working in a canopy management, climate change, and particularly from the horticulture discipline, they have to rethink on recommending or identifying some of the key training pruning practices, some of the key time, so that they can harvest a better crop. And I must say you should be avoid glut. So if you want to avoid glut, you have to change your pruning time. And if you want to change your pruning time, that means you are taking the risk. If you are taking the risk, you should be ready to invest more, not just not just in terms of input. Invest more your time so that you can harvest quality produce. Some of the farmers, you and me, we visited. I think certain area they are growing under plastic covers. They are using just for 10 to 15 to 20 days to cover the crops. So now we are having 1,60,000 hectare area. So the now time has come. This pruning has to be recommended to the growers or accepted by the growers, so that they can grow for a different period of times. Otherwise, this slight rise in temperature, because this increase in temperature is just not the temperature, 30 degree, 40 degree, it's coming with the UV radiations, it's coming with the higher intensity of light that may be infrared or that may be ultraviolet. They are triggering the metabolic processes, and these metabolic processes lead to the early or late harvest of the crop. This is a challenging area for all the researchers who wanted to work on the viticulture.
Okay, sir, fine. Sharmishta? Sharmishta?
Yes, sir. Yes, sir. We'll proceed with the other lecture, or any question is left. If any participant want to ask something from sir. So I think, sir, thank you, Nishant, sir. Thank you for your valuable time and guidance and suggestions. We'll proceed with our next lecture.
Okay, thank you.
Just give us 5 minutes. I'll because our next lecture is from Dr. Kaushik Banerjee, sir. I'll just ask him to join. So participants, give us 5 minutes.
Hello.
Hello, sir. Good afternoon, sir.
Good afternoon. Good afternoon.
So,
People are still there in our system. Okay.
yes, sir. Yes, sir. They are joined. So, our next lecture will be from Dr. Kaushik Banerjee on pesticide residue monitoring strategies for nurturing sustainable grape
Share screen.
production.
Oh, files.
It's an honor that sir is here and he's going to deliver lecture because sir is expert in this field, and I request participants to kindly listen to it because it's like a it's very rare that you can get such kind of information from personality. So you should all be very active and alert in this lecture. So sir, you can share your screen.
वही तो sharing में तो problem हो रहा है share screen then क्यों जा रहा है ऐसे basic ये ऐसे क्यों जा रहा है basic advanced whiteboard iPhone
डेस्कटॉप शेयर कर
एक मिनट computer ऐसे हो रहा है ideally इनको बुलाइए एक बार
शैलजा मैम को पूछती हूँ
शैलजा नहीं है आज कोई प्रॉब्लम है PowerPoint यही फिर से प्रॉब्लम है इसको जूम में मैं ये कर रहा हूँ जस्ट मिनट जूम में ये शेयर स्क्रीन अभी ये ऐसे क्यों जा रहा है ये भी नहीं आ रहा है
सर बेसिक में जाइए बेसिक में ना ऑप्शन होगा बेसिक में नहीं एडवांस में देखिए स्क्रीन पे क्लिक करके देखिए
ओ शायद 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 होगा देखते फॉर एग्जाम्पल ये देखो शर्मिष्ठा आ गए क्या हेलो
हाँ सर आ गया सर
आ गए हो गए
यस सर आ गया सर यस
ओके ओके थैंक यू ओके so good afternoon everyone so I hope you are all listening to me and now in next 45 minutes or so I'm going to inform you about various aspects related to pesticide residues in food items. So you know that pesticide residue is always a big problem, not only for grapes, but also for almost everything that we eat or we use in our life. So pesticide residue may come because of application of pesticide in the field. Pesticide residue may come because of indirect exposure, because maybe the farmer has not applied, but it might have been applied by the adjoining farmer. So by air, drip, etc., a pesticide may come in the agriculture commodity. In addition to that, our agro inputs like your manures, fertilizers, pesticides, your various other agro inputs like irrigation water, etc., they also may get contamination because of whatever way they get pesticide residues in their source. So this is the structure of the talk. First thing is that I will mention about current food safety concerns. Then I will let you know about residue management strategies, what is meant by traceability and good agriculture practice for pesticide residue management. And finally, certain national and regional initiatives for residue control. Now, you know that in the morning I was mentioning about agribusiness. So agribusiness means you consider agriculture as a business. So, for example, you develop a good crop. It's a very good quality grapes, looks very nice, very tasty. But suppose if you come to know that this contains a lot of pesticide residues, then who is going to purchase it? You will not purchase, I will not purchase, maybe no one is going to purchase that.
So pesticide residue is something which is sometimes highlighted in various media in such a way as if it is a very toxic substance, and people may develop a lot of health hazard because of exposure to pesticide residue. So that is the reason pesticide residue is viewed in a very serious way nationally as well as internationally. So first thing is that we often come to know about MRL non-compliance in trade. MRL means maximum residue limit. So it is the limit which is set by government bodies, like in India we have Food Safety Standards Authority of India. In Europe it is European Commission. In international level it is Codex Alimentarius Commission. Various other countries also have their own MRL. For example, Japan, then Saudi Arabia. Various countries are there who has their own MRLs. So MRL non-compliance means if a trade consignment is tested for pesticide residue, and if you find a residue level above MRL, so this means MRL non-compliance is registered. So if MRL non-compliance happens, then what happens? We say that basically we cannot accept the produce for selling in the market, and one should not consume it because there is a chance of health hazard. Second point is that why it happens, like why non-compliance happens, because sometimes there is lack of good agriculture practice for safe use of pesticide in many crops. So farmers do not know how to use the pesticide, what should be the recommended dose, or today if the farmer has applied pesticide, how long the farmer should wait before harvest. So all these problems often creates trouble, and sometimes it happens that farmers apply pesticide which does not degrade before harvest. So then at the stage of harvest, residues will be detected. Then third point is lack of testing facility, especially beyond the city areas. You know that you remember the COVID time that people used to tell that how to control COVID by testing and testing, more and more testing. So same is the case for food also. If food testing is intensified, or if food testing is done more frequently, then what happens? Gradually we come to know that what is a safe produce, what is not a safe produce. But unfortunately, in India, most of the testing labs, they are located in metro cities. For example, Pune, Kolkata, Delhi, Madras, or Chennai, Hyderabad, etc., etc. So remote cities often do not have pesticide residue testing facility. So even if you grow a very good quality crop in your village, it is possible that you don't have any access to a testing laboratory to test your product for pesticide residues. So that's a problem. So many times people, although they have a chance to export or chance to sell the produce in a better market where they may fetch a better price, but they cannot do it because they don't have access to testing laboratory. Then lack of awareness of regulatory requirement at farmer level. That means what are the regulations, what is a label claim, CIBRC has registration process, then MRLs are there, pre-harvest interval informations are there. So those things often farmers are not aware. So that is a major problem, especially if the farmer is non-educated. Last thing is that lack of product traceability and control on pesticide applications. So product traceability means if you go to the local market, if you purchase some fruits or vegetables or whatever, and if you face any health hazard by consuming that, whom should you contact? Like except doctor, you really do not have any idea that who is the farmer who produces that. So this is a big problem. So under this situation, it is important product traceability, so that if any health hazard happens or any complication happens, we can teach the farmer that okay, because of wrong application of pesticide or excess application of pesticide, the residues might have been detected. So next time he should take care of judicious use of pesticide. So these are the ways by which education can help reduction of pesticide residue problem. Now, in the beginning also, I was mentioning that food safety concerns are almost global. So it is not only for India. Everywhere we talk about food safety concerns. And crop like grape, for example, it is always in media. In 2003, when Indian grape consignments were rejected in Europe, that caused so much hue and cry that other export items for India also faced a lot of trouble. Sometimes we also listen that our basmati rice consignments get rejected. We come to know that sometimes our Darjeeling tea, Assam tea, they face trouble. So various issues of pesticide residue non-compliance, sometimes they come in the media, and that makes us confused that whichever food we are eating, what is the current scenario. So I thought to bring some good piece of information for you so that you can also understand that what is the current scenario of pesticide residue in various fruit and vegetables and other commodities. So in India, we have a national level pesticide residue monitoring program. It is called All India Network Project on Pesticide Residues. They have almost 23 centers across the country. Mainly they are working under various state agriculture universities. These are the accredited food testing labs under universities who normally does lot of market sample analysis. Like they go to farmers and from farm gate, they collect samples, and those samples they bring to the lab and then test for a set of pesticide residues. So this is the only report which is available in Food Safety Standards Authority of India's website. And if you look at the data, you will see that 23,660 samples were tested in India in that particular year, and only 2.2% were non-compliant to MRL. So you can understand that situation is really not too bad. The kind of information which we sometimes get that Indian food commodities are highly contaminated, Indian food samples are having a lot of pesticides, that is really not true as per this report. Similarly, I was looking at some other survey like FSSA had a milk survey, FSSA had edible oil survey. So those surveys also mention that very nominal percentage of samples actually were non-compliant for pesticide residue or other contaminants. Now, I was thinking that what internationally people thinks about India, if you compare with that, then you understand that whatever we claim in our Indian national monitoring system, whether that is really happening at international level also. Because India is a major exporter. India exports a lot of fruits and vegetables to various countries. And you know, grape is one of the major export item. Alfonso mango is an export item. Various vegetables like okra, curry leaf, these are exported to a great extent. So like All India Network Project on Pesticide Residues, which I mentioned about India, which is a project under Indian Council of Agriculture Research. Similarly, European Union also has a European Union Coordinated Control Program. And you see that there is a surprising similarity of their result with our result. Now, European Union, they import a lot of material from all over the world, which includes India. And they also have their member states. And this monitoring includes their nationally produced materials across the Europe and also the imported items. So they found that only 1.8% were non-compliant. So we said 2.2% for India, and for Europe it is 1.8%, very close figure. And in their situation, they tested 12,077 samples. And these are the other detailed information, like 68.5% were free of any quantifiable residue. So that means they were of zero residue, nothing was detected. Then 29.7% samples contained more than one pesticide, but residue levels were below MRL. So these are various statistical information which says that pesticide residue is not really a big problem nationally or internationally. What happens is that under our situation, we should be applying pesticide judiciously, so that whichever pesticide is applied, if it is done at a recommended package of practice, then it is expected that the residue level will be degraded before the harvest. So all over the Europe, there is another report like in 2020, more than 88,000 food samples were checked, and 94.9% of the samples were MRL compliant. So you can imagine that majority of the samples they are actually complying for various pesticide MRLs. Now, 2022 report of European Food Safety Authority, it is like a body like Food Safety Standards Authority of India or FSSAI. Similarly, Europe has a European Food Safety Authority. So you can see here that from India, certain commodities like chili pepper, they were detected for carbofuran, propiconazole, chlorphenaphyl. And this list does not have grapes or mango or any important commodity. Of course, rice was a failure item, which mainly happened for certain pesticides. But otherwise, fruits and vegetables like grapes, etc., most cases we are complying with our MRLs, European Union MRLs over the last several years. I told you that in 2003, 17 rapid alerts were issued against Indian grapes. And at that time, mainly monochrotophos and methomyl, these are the two pesticides which were detected in Indian grape samples. And that caused a lot of hue and cry across the Europe. Someone is talking probably. Please. Uh, uh, hello?
Kindly mute yourself.
Please mute yourself. So, yeah, so at that time, this monochrotophos and methomyl, these are the two pesticides which were detected in 17 consignments, which caused a lot of trouble. And that's the reason NRCGrapes, that means our institute, was identified as the national referral laboratory. And since then, we are controlling pesticide residues as a technical partner of APIDA, not only for grapes, but also for other fruits and vegetables. So if you look at the European Food Safety Authority's report of 2020, 2020, 2019, there also you will see that mostly our concerns were chili pepper, okra, kadiri, drumstick, rice, sesame seeds. But this list does not have grapes or any other fruits and vegetables. So that's a very good news for us. You see that mostly our fruit crops are free from pesticide residues, or whichever export is happening, that is straightaway accepted in most of the countries. Now, in case of green chili, for example, there is a problem like in Saudi Food and Drug Authority. They rejected several of chili consignments from India, especially Guntur area. So green chili is a problem, but now a lot of work is going on at state government level and various university level to promote good agriculture practices for such type of commodities. Now, if you look at the pesticides that various commodities are basically getting rejected, you will see that only few compounds are basically detected. So, for example, 2024, only chlorpyrifos, imidacloprid, thiamethoxam, tricyclazole. So these are the common pesticides which are used by the farmers. So nothing is very unusual. So if something is really applied and that is detected, we can simply say that, okay, you can reduce the application, you can reduce the dose of application, or you can probably reduce the frequency of application. So that should help in reducing pesticide residue problem. So similarly, tea, coffee, for example, I just thought to share with you some more information beyond grapes. The tea, coffee, earlier, once upon a time, we used to always listen that Indian tea, like Darjeeling tea, was getting rejected because of organophosphorus pesticides. But these recent years, hardly there is any detection. So in 2022, only one detection, 2021, only one sample failure. So rest of the case, like earlier, propargite, ethion, these are extremely toxic compounds which used to be detected in Indian tea samples or Indian coffee samples. But these days we don't get such type of problem. Instead, we are getting some issues related to nicotine detection. That is a botheration for Indian tea, because what is happening, this field level tea pluckers that whoever are working for harvesting, they use lot of chewing tobacco, khaini, etc. So this chewing tobacco, when they're using, so their hand has, their palm has lot of nicotine. So when they handle tea leaves and blossoms, so at that time, what is happening? This nicotine is transferred to the samples. So those consignments get detected for nicotine. So this is an indirect way of contamination. In case of fruits and vegetables, mainly we detect organophosphorus and carbamates. So these are the major issues. Like 2004 onwards, whatever pesticide residue monitoring we are doing for grapes, we are detecting mainly organophosphorus compounds. For example, there is a chemical called profenophos, which is an insecticide, and this chemical is detected in majority of the samples. So if you avoid detection of organophosphorus and carbamates, then still most of the pesticide residue problems can be resolved. So internal monitoring of grapes also mention that there are some other compounds like abamectin, for example. Abamectin is a chemical which is used for mite control. So sometimes before harvest, mites they attack grapevines, and then people applies abamectin. Chlorpyrifos is another commonly detected pesticide, not only for grapes, but for most of the commodities, because it is a multi-purpose insecticide, which kills a wide variety of insects. And fourth one is hexaconazole. It is a chemical which is used for powdery mildew management. And you know that grapevines have powdery mildew as a major disease. So it is a cheaper alternative as compared to various other fungicides. So what happens that hexaconazole, if it is applied before harvest, then there is a chance that it will be detected if the pre-harvest interval is not maintained. So I was mentioning about European Union coordinated multi-annual program, which started in 2000, a list of chemicals which are usually detected in their domestic samples, as well as the samples which they collect from various imported commodities. So this is the list of chemical, and you see that whichever chemical they are mentioned in red font, they are basically the chemicals which are detected in Indian consignments. So whether it is Indian fruit, vegetable, cereal, or whatever. So among all, these are the major compounds. So if you look at these chemicals like carbendazim, chlorpyrifos, cypermethrin, so these are the common chemicals which you all know that most of us are detected or usually applied by various farmers. So what is happening that these chemicals, if they are applied injudiciously or non-judiciously, then there is a chance that they will be detected. So in addition to that, pesticide residue problem often appears because of spurious chemicals. In our Indian markets, lots of spurious materials are available, which are major concern for the farmers and agrochemical industries. So what is happening that chemical formulation may name one particular chemical, but it may have adulteration with other chemicals. Many times it happens that herbal products or typically organically certified agro inputs, they may have deliberate contamination of pesticides. So if such kind of materials are applied, then what happens? There will be chances of detection of non-recommended chemicals. So for example, profenophos is the highest detected pesticide in grape every year. But if you look at the spray record of the farmers, you will never find a profenophos in the spray record. So farmer did not apply profenophos as such. But why profenophos is detected? Because profenophos is a contaminating or adulterant in maybe other formulations. Then in this year, not this year, in actually 2023-24 last grape season, what happened? We detected ivermectin. So ivermectin is it is used for animal insect control. So this was detected, and that created a lot of problem because we did not have this chemical in our monitoring program. And when it was reported in some of the Indian consignments from Europe, that was a surprise for us because it is not a chemical for plant insects. It is mainly used for animal insect management. So then ivermectin was included in our testing protocol, and then problem was solved. Metrin is a chemical which was detected in 2018 and 2019 in some of the grape consignments. It's a very interesting story. Like from Nasik, some of the consignments were sent to Europe, and those consignments, some five or six consignments were detected for metrin. Now, when it was reported to us, it was such a surprise for us that we never heard of metrin earlier. So when we Googled metrin, then we found that it is a Chinese herbal medicine. So China has their own system of medical treatment, and it is a herbal product. But this herbal product, although it is used for human disease management, it also has certain limited insecticidal activity. So some of the materials which were sold from China source in Nasik market, they had mainly nutritional materials like various macro and micronutrients, but they had this particular herbal extract. So when it was used, the samples were detected for metrin and its oxygen analog, which is named oxymetrin. So it was a huge problem for us. Then we had to see a lot of literature. And from European Union, one particular laboratory the head, he helped us in supporting with the analytical protocol. So then we immediately included it in our monitoring program, and we found that many of the samples were detected for metrin and oxymetrin. So that time, then we had to do almost a door-to-door campaign through the network of State Grape Growers Association, and that helped us in minimizing metrin detection. So last a couple of years, we never detected this chemical again. So many of the biological and natural product formulations which are typically promoted in field, that these are the materials which are for organic cultivation, they have pesticide adulteration. So this is a big problem, that if such type of materials are used, then what to do? So then season of pesticide detection, but finally they face trouble of sample failure. So there are certain I mentioned that various organophosphorus and carbamide pesticides are still detected in Indian food consignments. But main concern is that these chemicals are mostly either banned or restricted in other countries. For example, I talked about monocotophos, which is banned in Europe since many years. And in India also, it is highly restricted in most of the commodities. Then methomyl was also highly restricted because of its extreme toxicity to mammals. But these are still used in India because these are having double claim or registration in our country. Then toxicity to human health. So there are apprehensions of health hazard and potential toxicity to non-target organisms. So for example, monocotophos was banned in Europe because it had toxicity to bird population, avian population. So lots of birds were dying in Europe. Then they with monocotophos application. So these are the reasons why detection of monocotophos causes a lot of problem to Indian trade. So Indian grapes, fortunately, annually we never detect more than 1 or 2 cases, but sometimes almost a nil detection of monocotophos. But if it is detected and if the sample fails, then it is a very difficult situation for us to justify that why monocrotophos was applied by the farmer. But simple reason is that these are still available. These are cheap chemicals and these are still effective chemicals. So that is the main reason why poor farmers are still applying them. But if they are applied without maintaining a sufficient time before harvest, then there will be every possibility that residues will be detected. And if residues get detected, then there is a huge problem of trade. And sometimes what happens that your consignment will be failing there. Your consignment, they will say that we have to dispose. So in Europe, what they do, they burn it at a very high temperature. So they put the consignments to incinerator at a very high temperature, like more than 1000 degrees Celsius. They burn the material into carbon dioxide and water. But then for that, whatever cost is involved, that also they charge from the Indian business people. So it's a huge loss for the Indian agro industry. So what are the main takeaway things? That only a few pesticides are usually detected, and most of them, if you you will see that most of the chemicals they do not have a CIBRC level claim. You know that in India, Central Insecticide Board and Registration Committee, CIB and RC, this is the body under Ministry of Agriculture who is entrusted with the objective of registering pesticide. Now, pesticide registration is a long process. Like farmers, they are able to apply a pesticide in the farm only if a pesticide is they bring a pesticide in Indian market, they have to first register it. They have to generate data on its bioefficacy and residue. So those data are generated by ICR institutes and state agriculture universities. So once the data is generated, that data in a prescribed format, they CIB and RC evaluate those data. And after all the data evaluation, if everything is fine, then they send the files to Food Safety Standards Authority of India. Now in FSSAI, there is a scientific panel who evaluates the data further and they estimate the maximum residual limit for the country. So once the maximum residual limit is estimated, then pre-harvest interval is recommended. And that means if you apply the pesticide today, pre-harvest interval is the number of days after which you can harvest. That means this much time will be required for the pesticides having long PHI. Sometimes what happens that is not really good for agriculture, because if the pesticide takes a very long period of time to get degraded, then there is every chance that those pesticides will be detected. Like carbofuran, etc. They used to remain stable for a very long period. And if the pesticide remains long periods stability, then what happens? There is a chance that they will be detected. Then many crops like curry leaf, drumstick, coriander leaf, they do not have any pesticide with label claim. Lack of product traceability is another big problem. I already told that if you purchase something from market, you don't know who is the farmer who produced it. So all these are major problems which are getting solved largely in our country on at least certain sectors. I will inform those. So instead of thinking too big, we should manage such crop pesticide situations. Probably sometimes what happens, instead of criticizing the situation negatively, if we just evaluate that why farmers are still using certain pesticides which are not recommended or not used in other countries, maybe because of financial reason, because of economy, since these particular chemicals are cheap and still effective, that's the reason probably they are using. The only problem is that we don't have recommended package of practice. So and the pathologists, they work on those chemicals, and if they develop package of practice for the farmers, then probably their residue problem can be resolved. So regarding product traceability, I would like to inform you that product traceability is something which is a regulatory subject, and European Union came out with a regulation in 2002, and this is a very famous regulation. It's a sort of mother regulation, and based on this, in India, in FSSAI also we came out with a similar type of system. And so here traceability is the ability to trace and follow a throughout all stages of production, processing, and distribution. So, for example, grapes are grown, grapes will be cultivated, and during cultivation process, all the operations like every package of practice related to application of pesticides and other agrochemicals, everything will be recorded. Then after grape is harvested, that is brought to the pack houses, they are packaged. Is a local market or it is exported to other countries. So it is a distribution channel. So production, processing, distribution. Processing happens sometimes like grapes are processed to resin, grapes are processed to juice, grapes are processed to wine. So during the entire process, if we come to know or if we have information that what is the traceability of the material, from which location to which location it is going. For example, if you compare it with any courier service, we local head office, then it is transported to the other city, destination city. Then they also mention that how it is finally transported to the is tracked in a courier service. So similarly, in case of agro produce also, say similar sort of traceability system is being used. So for example, if you look at this particular scenario, that if this is a piece of land, say for example, 1 hectare area, every 1 hectare area in Maharashtra who is interested to export for Europe, they receive such sort of 14-digit code, which starts with the first this two letters like MH. MH means Maharashtra. Similarly, if it is Andhra Pradesh, then it will be AP, Telangana TL, then if it is Karnataka KA, Tamil Nadu TN, like that. So then there is a mention of district code like Nasik, Solapur, Sangli, etc. Every district has its own code. Then sub-district code, product code, farm code, and plot in question. So if this is a code, it is just like a postal code. And this postal code is pasted on every box of grape, which is destined for European market. So for example, if this is the grape box, you will see that there is a label, and in that label, it is all information are mentioned. So you are finding that there is a farmer code. So from this farmer code, you get to know that who is the farmer, what is his address, what is his phone number, what is his email address, which variety of grape has been exported, and origin, it's a class. Class means it's a AgMark classification. You know that AgMark is a standard of India. There is a Directorate of Marketing and Inspection under Ministry of Agriculture. They give various classes of grapes and various other commodities. So if it is mentioned that class one means very good quality grape. And the best quality material is usually mentioned as extra class, and little bit inferior quality of materials are mentioned as class 2. So these are basically quality classification. So even the net weight of the box, 4 kg, 10 into 400 gram, that means in small punnets of 400 gram, 10 boxes will be there inside this big box. So this way, if the material is transported to Europe, then tomorrow, if any pesticide is detected in this consignment, the European authority simply mentions about the farmer code, and we get to know who is the farmer. Then what we do, we go to the farmer, we speak to him, we ask him that why your material has been rejected because of pesticide residue. Did you apply this pesticide, or did you apply this pesticide as per the proper recommended package of practice? So all these questions are asked. So many times it happens that farmer may not be aware of the information. So at that time, teaching the farmer resolves the issue. Like next time he should not commit such type of mistake. Sometimes it happens that it's a false detection. So we take care of it by challenging the detection in Europe and try to solve the issue between these exporter and importer. So if you go through the website of Apida, you will see that initially Apida started with GrapeNet. GrapeNet is a food safety traceability system for table grapes. I told you that in 2003, there were some consignment failures in Europe because of detection of monocotophos and methomyl. So at that time, GrapeNet was started. So after that, they brought various other commodities like pomegranate, mango, various vegetables, etc. So for example, if you look at this particular homepage, it is the homepage of Hortinet. So all horticulture commodities they are bringing one after another. So you can see that we have grape, pomegranate, mango. Under vegetable, there are so many vegetables. Similarly, betel leaf is there, citrus fruit is there. So betel leaf is basically for salmonella. So these type of things are there. It is a continuously growing, like more and more commodities are bringing or are brought into the traceability program. So what is happening under this traceability, this registration of the farm with the state horticulture department, that is the most important thing. You know that state department has the land records, so they give a unique registration code to these farms, and then after that all the activities starts, and we are functioning as the national referral laboratory in this system. So our job is mainly to develop technology, disseminate the technology, recommend package of practice, and do all sort of things for appropriate testing with high accuracy and precision. So NRCGrapes does not do commercial testing. What NRCGrapes does, NRCGrapes develops the protocols for testing, and there is a huge network of testing labs. So these testing labs are registered with Apida as well as FSSAI, and they are accredited laboratories. And these accredited labs are actually doing commercial level testing.
Kindly unmute yourself.
Pranjal, please unmute. Please mute. Okay. So all these things are happening like there is a huge procedure in this. And not only this, after pesticide residue testing, if the consignment is cleared, like if the consignment is found to be MRL compliant, then there are two more activities. One is AgMark. I told you that extra class, class 1, class 2, such sort of things are there. These are not only for grapes, but other commodities also. Every commodity has AgMark quality standard. And if you look at the Directorate of Marketing and Inspection, their website, you see that AgMark quality standards are mentioned. And these are mainly in compliance with the Codex standard. And once AgMark grading happens, after that, another requirement is phytosanitary. So phytosanitary is basically they are in quarantine pests, quarantine insects, diseases, etc. So if everything is cleared, then material can be exported from India. So all sort of things, these are all coordinated and interconnected. So then this is the way by which this Hortinet system, including GrapeNet, is working. And here, every agency has been given their user ID password. So they log in and they do all the things. So these are basically internet driven activities. So in case of food testing labs, what happens? There is a network of laboratories who reports to us. So our job is to inspect those laboratories. And then if we find that lab is good, then what we do, we organize a proficiency testing for them. So proficiency testing is basically just like an examination. We send them a sample containing unknown pesticides for them. Pesticide residue have to be detected by them, and they should identify and report the concentration. So since the accurate concentration and accurate names of the pesticides are known to us, we compare their result with our result. So there is a system like proficiency testing, which is a statistical procedure by which we decide that uh, whether a particular lab's performance is satisfactory or not. So once we find the laboratory performance is satisfactory, send a list of labs, list of recommended labs to APIDA, and then APIDA allows them to draw sample and test the material for export. So for sampling also there is a requirement that the samplers require proper training. So we provide training at our NRC grapes, and then the trainees, they receive certificate after completion or after successful completion of the training. So after the training is over, then what happens? After the training is over, their signature is also provided to APIDA. So every box of grape or any fruits, vegetables, whatever they collect, they have to sign it on the box. So, and those authorized samplers are only allowed to draw samples. So this is the entire system of traceability and quality management system. So there is a gap document like good agriculture practice document that is basically used for minimizing pesticide residues. And there are certain recommendations are given like pest specific recommended pesticide, dose or application rate, maximum residue limit, and pre-harvest interval. So these are the major information which we provide. For example, if you look at this particular document, this is every year we update this document. And here you see that we are giving the list of pesticides, their nature, like it is a systemic chemical or non-systemic or contact chemical. Then what is the latest MRL for Europe? Then what is the dose on formulation basis? And what should be the pre-harvest interval? So if the pre-harvest interval is 59 days for the first entry, that means if the farmer is applying this particular formulation, then they have to wait at least 2 months period before harvest. Otherwise, there is a chance that chemical, for example, amisulbrum, that will be detected above MRL. So these are certain things. And on the right hand side, you are seeing the procedure for export of fresh table grapes to the European Union. It's a document, and this document is this is the latest updated document in the website. But every year, if there is a requirement, it is continuously being updated to cater the requirement of our system. But every year, this list of chemicals with CIB and RC level claim for use in grapes, that is compulsorily, it is updated based on the recent updates on level claim information for pesticides. So harmonization of residue test protocol is another big thing which we have recognized and organized. Like in 2004, when we started the residue monitoring program, we found that before that only a few chlorinated hydrocarbons were tested. So after that, we found that many chemical which directly or indirectly may appear in grapes during the cultivation process, they need to be brought into the testing protocol. So every year we went on increasing and increasing the number of chemical for pesticide testing. And in 2010, the list was expanded to 98 pesticides. Now in 2010, there was a detection of plant growth retardant named chromic chloride. So that created another big problem for Indian grape industry. And then uh, it was understood that we have to also start monitoring plant growth hormones. So plant growth regulators or bioregulators, they were brought into the system of monitoring. So for example, GA, CPPU, all other whichever chemicals are used for as plant growth regulator or plant growth retardant. So everything was brought into the system of monitoring, and it also includes all the herbicides like glyphosate, paraquat, diquat, everything. So these are the screening capability. Like as NRL, we have developed capability for analyzing more than 400 pesticides, but actually 280 plus chemicals are tested in every consignment because these are the chemicals which are having relevance for India. But capability wise, our laboratories in India, they have a huge capability. They can test probably any pesticide which are required to be tested. Now, success story on grapes. I told you that so much happened for grapes, and in 2003-4, when we started our residue monitoring program, almost close to 24% samples they failed for European Union MRL compliance, and this has been reduced to 2 to 3% in the last 3 grape season. So again, I told you that our Indian report was for around 2% sample failure. So in our grape net also, we are finding not more than 2 to 3% sample failure. So these national and international data, these are all having a similarity with each other. Some case study like flucilazole, which is a chemical which is used for powdery mildew control. In 2005-6, there were 281 detection. And if you look at in the last few years, it is almost negligible detection. One big success is for dimethoate. It is organophosphorus chemical, which is of extremely toxic category. Now, dimethoate was detected in 341 detections. So you can imagine that 341 detection means 341 samples failed in India, within our country, within our national monitoring program. So if you think of that, one sample was drawn from 1 hectare area, that means we are talking about grapes from 341 hectare area. And if 1 hectare produces approximately 20 tons of grapes, so 341 into 20 tons of material, huge amount of material could not be exported because of detection of this dimethoate. So what we did, we intensified our extension program. There was lots of farmers teaching programs, local advisories, etc. And that caused this success story that 2010-11 onwards, there was no detection of dimethoate. Similarly, chromic quat chloride, I told you that more than 40% of the Indian grape samples were detected for chromic quat more than MRL in 2010. And this was immediately in next couple of years, this was managed in such a way that in 2016-17, it reduced to less than 1%, only 0.7%. And every year now, out of 10,000, 12,000 samples, whatever we test in our country, hardly 20, 30 samples will be failing for chromic quat, which is below 1%, of course. Success story for okra and curry leaf is another thing which, although it is not directly related here, but I just tell you one example. Like in 2012, we had a huge problem for okra and curry leaf. Lots of samples failed, and European Union, they almost put a ban on them. They said that every okra and curry leaf consignment must accompany a pesticide residue testing report, and they brought a new regulation in 2013, 31st January, the EU regulation specifically concerning pesticide residue in okra and curry leaf. So they said that from India, these consignments should be accompanied with certificates stating that products have been sampled and analyzed for pesticide residues. So similar to grape, we also developed one procedure for export of okra to European Union, and this worked so well that we developed a residue monitoring program. Sampling and residue analysis protocols were validated by our institute. We provided training to all the labs. We organized proficiency testing. Then pre-export residue test for a defined list of pesticide made compulsory. So this type of traceability was established, although it was not for grape, not like grape. It was mainly for post-harvest sampling. And all these activities could manage pesticide residue problem in okra in such a way. Then in 2018, 2nd July, this regulation came up, which says that special import conditions are withdrawn for Indian okra and curry leaf. They mentioned that there is a substantial improvement in the quality of okra from India. And there's a reason this special import restriction, which was imposed on Indian material, that was withdrawn. Now FSSAI has its own MRL. FSSAI initially established more than 200 pesticides MRL in 2018 December. So for example, this is the gazette notification. you see that this is still valid, but now it is being upgraded. So at that time, almost 213 pesticides were notified for their MRLs. So these are our domestic MRLs, our local MRLs for our country. So India also imports a lot of material from other countries. So those materials are basically checked in with reference to these MRLs. So if any apple, grape, or anything is imported to India, one should look at our Indian MRL. So out of this, 160 MRLs were 0.01 milligram per kilogram. That was very stringent. So this mainly happened because residues were below detectable limit at the date of risk assessment. So now, since it's a trade issue, like sometimes our MRL is much below than European MRL, which were set. So now we have revised these MRLs, and we are increasing the MRLs from the lower level to higher level to mainly harmonize with the codex limit, so that our material is equally competitive, and we can also give comply with the trade agreement as per the WTO. So if you look at like some of the MRLs have been revised, like in this case, grape cyazofamid, which was 1, now it is 1.5, 0.05 to 0.2, like that. This type of MRL revision has been brought in. So revision of the default MRL, if MRL is not available in India, our regulation says that it should be set at 0.01. So 10 parts per billion or 0.01 milligram per kilogram is the default MRL. So if any pesticide is detected in any sample or any consignment, and if national MRL is not available, then it should be used as 0.01. But this is the same value which is also considered in Europe as well as in Codex by FAO, WHO. But in case of spices only, there are some relaxation. They said that in case of spices and culinary herbs, the tolerance limit shall be 0.1. Now, strategic residue management practices, I'm almost at the fag end of my presentation. You know that there are strategic residue management practices which are basically used to minimize pesticide residues. Like first thing is that establish product traceability, then establish good agriculture practice recommendation, and residue testing of traceable samples. So these recommendations, once they reach the farmers, then only their actual benefit can be accrued. So for that, basically, state government and growers association, exporters association, they can play a very significant role. Even the influential farmers, who are the role model for the small farmers, if they are trained for various good agriculture practice recommendations, then location-specific weather forecasting advisories are very important to ensure or regulate need-based applications of pesticides. Training programs for stakeholders on a regular basis. So main idea is that you try to reduce pesticide applications in such a way so that they are used only when they are absolutely necessary. Similarly, control on cultivation, control pesticide applications, pre-tested formulations, training. These are the most important thing. Bio-intensive strategies are taking up or shaping up in such a way that people are trying various biological agents. You will be having a separate presentation on that. Various beneficial organisms are there which can control very effectively various insect pests as well as diseases. And if they reduce pesticide application or chemical pesticide applications, that is a fantastic possibility of minimizing pesticide application and reducing their detection. So there are various initiatives like establish product traceability, bring more pesticides under the label claim regime so that farmers have a wider choice. If the farmers are given 5 or 6 chemical choices for each and every pest in any crop, that is the best idea. So that if different pesticide has different pre-harvest interval, the fastest growing chemicals can fastest degrading chemicals can be applied at the later stage of the cultivation. And if a chemical is a slow degrading chemical, then that pesticide should be applied in the early stage of cultivation. Harmonize MRLs at the global level, that actually promotes the business, because we want to export as well as we need to import. So export and import, both things continue. but we should reduce our import, enhance our export. That earns a lot of foreign exchange for the country, and that also helps improving the farmers' income. Establish and implement a good agriculture practice through integration of stakeholders, extensive residue testing facilities across countries. So across the country, government is also providing a lot of support, like Ministry of Food Processing Technologies, APIDA, then state departments, they are providing support to various laboratories in regional levels to grow their facility, so that if they have some minimal facility, that can be probably expanded by uh, purchasing advanced equipments for pesticide residue testing. Then bring all registered pesticides under the residue monitoring program, so that expanding the scope, so that every sample can be tested as many pesticides as possible, so that whatever safety we decide or recommend, that should take care of maximum number of chemicals. Evolution of a strategic plan for comprehensive food safety assessment and extensive extension activities for transferring good agriculture practice recommendations to farmers. This is a very, very important thing. And for extension activity, probably it is a responsibility for all of us, whoever are attending this lecture. If you do your own job of teaching the farmers, teaching the stakeholders, whomever you know, that pesticide should be applied judiciously. Pesticide should be applied as per the level claim. Pesticide should be applied maintaining the pre-harvest interval and application rate. So all these things are very easy to understand, but very extensive effort is required to teach the farmers so that they comply with the regulations. Now, export control through Hortinet is largely successful, and more such models are replicated in other crops. Now people are talking about putting system for basmati rice also. So if you look at the APIDA website, they say that though India's share in the global market is still nearly 1% only, there is increasing acceptance of horticulture produce from the country. And this has occurred due to concurrent developments in the areas of quality assurance measures. So quality assurance measures are so important that every aspect is required to be evaluated for quality assurance. So quality compliance, quality assurance, these two things are so important that if that is maintained, then probably our material will be straightaway accepted. If our material is not accepted, then lot of trouble. So better to grow the crop in such a way so that material is exportable, or material, if it is not exportable, uh, export is not the only thing. We are growing crops for our domestic consumption. We eat at our own home. Our relatives, they eat. Our children, they eat. Our brothers, sisters, mother, father, everyone is eating. So we should eat the best quality material in our own country. And then next question is that when you are doing processing, then processed commodity also should be free of residue. So if you want to do that, probably it is a shared responsibility. Every one of us should do our job properly. We should teach the farmer, and farmer, they are doing actually fantastic job in case of grapes. I told you that pre-harvest monitoring, giving only 2 to 3% sample failure, that too in the national monitoring, and in export almost zero rejection. So that is a role model in the entire world. So farmers are already doing great, but such type of protocols, such type of models should be replicated in other commodities also. So similarly, consumer organizations, academia, like we are belonging to academia also. We are teachers, we are students, we are faculties, we are trainers, and the various scientific institutions. Everyone should contribute to their capacity. So if that happens, then only probably we can achieve the food safety. And if food safety is achieved, agri business is promoted. If food safety is achieved, then naturally material can be sold at a higher price. And if material is sold at a higher price, then farmers get better share of the profit. So that contributes to their better living, contributes to their higher standard of livelihood. So with this, I conclude here, and thank you very much for your attention over the last 1 hour. Thank you. So if you have any question, most welcome.
Participants, if any one of you have any questions, you may please ask, sir.
Number of participant has also reduced now.
Probably.
Uh, Thanks, sir, for a very informative Girish to everyone. Okay, most welcome.
But sir, most of the participants joined on YouTube, sir.
Oh, is it? Okay,
Yes,
okay,
yes,
okay.
sir. More than 50
Hmm.
on YouTube, sir.
Oh, that's so good.
Yes,
Acha.
yes,
Oh, okay, okay, okay. And many people may be joining together,
yes, sir.
so
That is
we cannot count that way. Good. Today, is there any further talk today, or is this the last one?
This is the last
I
one.
have,
Last
sir,
one.
I have one question. Should I ask you, sir?
Yeah, yeah, please, please.
Sir, first of all, I really appreciate your lecture, sir. Very brief and very precise lecture, sir. Sir, the certain MRL levels or criteria has been given in the form of annexures, particularly export purpose. So, will it possible? Will be it will be also decided for your domestic market, particularly in India. What's your view, sir?
Yeah, that I told you already, no? That in the last couple of slides I showed you that that FSSA has their MRLs. Now system is that after 2014 or 15 probably, whichever pesticide is registered in India, there are two things. One is that pesticide company, whenever they submit their application to CIB and RC with all the registration data, then what happens? So the CIB and RC uh, further ask that what should be the MRL and PHI. So for that MRL and PHI, basically they send the files to FSSAI. The FSSAI scientific panel decides the MRL. Now I told you that in 2018 December, 213 pesticides, their MRL was decided in our country. And now another gazette notification is awaited where some more MRLs have been decided. So lots of MRLs are available now in our country, various pesticide and uh, crop combinations. So based on that, PHI is calculated, and that PHI is a part of the level claim document. Like every pesticide bottle will have one document, 1 page, 2 page information that usually has all such sort of information that on which crops this pesticide has label claim, and if it is recommended and applied as per the recommended application rate, then how many days should be the PHI. So this is very much available for our domestic market. And for MRL, you know that our institute is working as the referral lab for FSSAI. So we are receiving so many apple samples these days. We hardly get any grape sample, but apple samples are coming a lot. And those apple samples, several samples have failed in our testing. So that means we are also failing lots of imported material based on these FSSAI models. So not only our material is rejected there, we are also rejecting a lot of material which are coming from other countries. So India is having more and more stronger regulatory system in our country, which is a very good thing. And I think this is going to improve further in days to come, because FSSA is doing a lot of work for domestic food safety.
Sir, Dr. Arusa Khalil has a problem to unmute because we haven't have anything from here. So probably there is some technical problem at their end. So she's asking, sir, as we procure grape from the market, how can the customer ensure that he's taking healthy grapes?
That is difficult to ensure, but what happens that most of the grapes are good these days. You see the statistics. Every year, more than 40,000 farmers are registering for export. They are maintaining all sort of regulatory practice for maintaining pesticide residues. But actually, maybe 10,000 farmers are actually they're exporting. So almost 35,000 farmer materials, they are coming to the local market. They could not export, probably they did not get business transactions finalized, or whatever reason they did not export, but they are getting a good price in our local market also. So every year we also do a lot of testing of our local produce. And I also mentioned about our All India Network project on pesticide residues. They also say that less than 2% of the material is actually detected for above MRL uh, situation. So situation is quite okay. Grapes are really safe these days. Only thing is that probably you can wash it properly with water. And if you wash it properly before eating, then I don't think any problem. So enjoy fresh grapes. And now most of the pesticides which are recommended in grape cultivation, they are also quite safer as compared to the old generation pesticides. And I told you that in my slides that toxic chemicals like dimethoate, etc., or various organophosphorus and carbamates, their detection is very nominal these days. So it's quite good. And if little bit of pesticide residue is there, don't bother, because what happens, we have a very defined metabolism process in our body. We have enzymes, they degrade pesticide residues. If it is a very small quantity, it doesn't matter. We have a fantastic metabolism process by which these pesticides are degraded. And drink a lot of water, drink healthy food. So a little bit of pesticides will automatically go out of your body. Thank you.
Thank you, sir. It's been a very informative lecture. It is also important for a day-to-day. All these things are important as we consume so much of vegetables, fruits, and other things. So it's been a very informative lecture. Anyone else who want to ask any questions?
Sir, one more query.
Yeah.
Sir, now the Maharashtra state government has added as a food commodity, that is the resin in midday meal scheme.
Yeah, yeah.
But most of the farmers are using the sulfur for just taking care of the resins and also for some color improvement like that.
Mm.
So, sir, how it can be managed, because it is ultimately it will be eaten by these childrens. So, what should be the quantity of the sulfur, or your view, sir?
I think this is a very important concern for us. See, resin is very good for health. But I was talking to some of the resin growers recently who visited our institute, and uh, probably that sulfur dose is not standardized. They sometimes they say that uh, they don't know how much time and how much amount of sulfur should be used and how long the exposure should be given. So these things are not really the same for all the resin farmers. So they are using sulfur for various reasons, to bleach it or to give it a attractive color, or sometimes to prevent any spoilage. So various reasons are there for which sulfur treatment is given. So, but sometimes it happens that farmers may not be aware that what should be the minimum amount or what should be the maximum amount of sulfur, and what should be the maximum exposure time for sulfur fumigation. So these two things probably we need to optimize and teach the farmers so that sulfur content is less. But otherwise, if it is a below, if it is a optimized level, it should not be a problem, because earlier when we started our residue monitoring, at that time sulfur had a MRL for pesticide as a pesticide in Europe. But then in European Union, they have removed sulfur MRL. They said that sulfur is also an element of nutritional category, and sulfur is also a part of or component of various amino acids. So that is the reason they said that sulfur being a part of amino acid as well as various enzymes, that sulfide group, etc. So they removed sulfur MRL now from the MRL database. So that is the reason I think food safety wise there may not be big issue, but too much of sulfur definitely there. Sometimes people say that they cause a little bit irritation in the tongue, etc. So I think it's more of teaching and extension of good agriculture practices related to sulfur usage that we need to do from our institute and through our growers association programs.
So Girish sir has a question. Anything to be concerned us about nicotine contamination in tea?
Nicotine contamination in tea is a concern, of course. That is a problem for tea, which European Union has flagged. But I don't know what is the solution. But because nicotine is water soluble, but its concentration is not really too much, and health hazard wise also it's not a big issue because concentration wise, finally whatever is coming in drinkable tea, whatever concentration they mentioned, it's quite nominal, because once the tea leaves are plucked, then a lot of processing happens. So it's not that whatever the raw material has same material when it is processed, after that residue level of nicotine is much less. And we only use maybe 1 spoon tea powder or tea leaves for preparing out 2 cups of tea or 4 cups of tea. So concentration wise, whichever nicotine we are getting exposed, that may be very small. And nicotine is becoming highly water soluble. If you drink a sufficient amount of water, then it should be moving out of your body. So don't bother much about that. Main problem is that our farm laborers, they use a lot of chewing tobacco. So this requires more of social teaching, that if they are taught that chewing tobacco is not good for health, that causes concern. So those things are required at labor level in tea gardens, which probably tea industry has already started. Any other question?
Sir, one participant asked one question, it is in chat box. Why those Middle East Asia countries won't prefer any residue analysis test or criteria?
No, they are also preferring Middle East and other countries are very much, they are asking for testing. For example, I told you about Saudi Food and Drug Authority, SFDA, then Dubai Municipality. They have a very good lab now, and they are very much imposing lots of restriction on our material. So whatever commodity they are importing or whatever commodity they are growing, well regulated these days. So it's not that not like that they don't want. They also are expecting a lot of food safety issues to be complied at their level.
One more questions. Is there any possibility of smart kits that will detect pesticide on field level?
So smart kits, some kits were available once upon a time, and still some kits people tried, which are mainly for organophosphorus and carbamate pesticides. You know that these kits are mainly working on that acetylcholinesterase enzyme based activities. So these kits are only able to detect some selective compound. But pesticide residue problem is so diverse that at a time multiple types of pesticides may be present in a sample. So kits really do not work under that situation, and kits also are unable to detect and quantify pesticide residues accurately. So that's another problem. And pesticides, if it is a contact pesticide, then it is on the surface. But if it is systemic one, then it goes inside. So then sometimes kits are unable to detect those compounds properly. So foolproof kit is not available at this point. Even some people tried about various infrared and NIR based strategies, but those are also not very successful in case of pesticide residue analysis.
So I think
We are done.
yes, sir. So thank you so much, sir, for your
Okay.
valuable lecture and time.
Most welcome.
Tomorrow we all will be present again at 9:30. Dr. Prashant Nikumbe sir's lecture will be there, Biotic Stress Management for Sustainable Grape Production. Right, sir?
Yes, ma'am.
Okay, so tomorrow at 9:30, you all please log in and be ready so that you can hear to sir's lecture. Thank you so much for today. We
And
are done.
tomorrow also there will be a possibility of that YouTube, is it not? So that also we can circulate separately. Probably.
Yes, sir. Same link has been sent to all participants, sir.
Okay,
Yes, sir.
very good.
Yes, sir.
Thank you. Okay.
Thank you, sir. We all can leave now, and for
Yeah,
tomorrow,
yeah.
you all please join at 9:30. Yeah. Thank you. Thank you.